so 5-2, there's still two parts that we haven't gone over. One is the logs, the graphs of the logs, and then one is the LNs. So we're going to see how far we get today. We'll finish it tomorrow. I made the assignment combined because I don't know where we're going to get. And I made it due Thursday. So my advice is to cover, we're going to do the graphs first. And then I would go through the homework tonight and do all the graphs, and then it leaves only a little bit for tomorrow because otherwise it's a long assignment if you leave it all for one day. So we're going to focus on the graphs of logs. These are the inverses of the graphs of exponential functions. So if you remember the graphs of exponential functions, your parent function rose as you moved from left to right. It was increasing. If I take all those x and y values and I switch them, it creates the log function, which will start at there will be a vertical asymptote this time at 0, and it will increase as you move to the right. The biggest thing is that when we graph logs, we plug in for y. So instead of plugging in for x, we plug in for y. And then really everything switches, but instead of having to create it as an exponential function and then switch it, we just plug in for y. So you're going to set up a t-chart just like you did with your exponential functions, but instead of plugging in for x, you're going to plug in for y. That's the biggest difference with exponential and logs. And then when you're finding out your information and the directions on the homework say it, you're going to have a vertical asymptote instead of a horizontal asymptote. You're going to have an x-intercept instead of a y-intercept. You're still going to have domain and you're still going to have range. And the range would be negative infinity to positive infinity, but the domain is going to be restricted based on your vertical asymptote, okay? So if you remember exponential, the domain was all real numbers, the range was restricted, we switch it. So everything that applied to the y now applies to the x, and everything that applies to the x now applies to the y. All right, so it literally says graph the log function. This time we are first looking for a horizontal shift, because that's going to cause a shift in your vertical asymptote. How do you look for a horizontal shift? Think about your functions that have exponents, right? Or absolute value. What is it? Hadley, you said it. Inside the parentheses or inside there. So if there was something other than just that x next to the log, then there's a horizontal shift. If there's not, then your vertical asymptote is at x equals 0. So that's the first thing you want to look for. It moves with a horizontal shift. So if it said x minus 2 in there, that's a shift to the right 2. You'll see that in a second. Then we set up our t-chart, and instead of plugging in for x, we plug in for y. I'm going to take my function, y equals log base 2 of x, and I'm going to convert it to exponential. So the 2 comes over and picks up the y, drops off, leaving the x. And then I plug everything into that. So 2 to the negative 1, 2 to the 0, and 2 to the first. 2 to the negative 1 would be 1/2. 2 to the 0 would be 1, and 2 to the first would be 2. So we plugged in for the y, and we got the x. And then I plot those. 1/2, negative 1, 1, 0, and 2, 1. And my curve does what it's supposed to. It gets as close to the vertical asymptote as possible without touching it, and then it points up to the right. Because it's a log, so we switch it. Yep. 3 is fine, as long as you can figure out your curve. So now I've got a domain that is restricted. It starts at 0, but doesn't touch it, and it goes to positive infinity. That domain will also be based on your horizontal shift. If there's none, it's 0. Your range, those arrows point down and up. It is negative infinity to positive infinity, as it would be for every log. And you have an x-intercept this time, and that's your middle point, or the point on your graph, which is 1, 0. And then we wrote it up here, but our vertical asymptote is at x equals 0. So on every question on the homework, you got to give those things. You got to give the t-chart, and then you got to hand draw it, and then you got to give all those information. I literally put it on the Canvas assignment, but I just want to reiterate it because God knows you guys don't read. Summer. Domain is based on your vertical asymptote. So if your vertical asymptote is at 0, it's from there to positive infinity. It's going to shift, though. You're going to see it shift, and we're going to talk about it in a minute. Okay? So that's, you look first there. Is there something being added or subtracted in parentheses with that x? And that's what would cause it to change from 0. All right, go to the next one. What is the base on that log? 10. So y equals log base 10 of x. Is there anything in the parentheses with the x? No, which means my vertical asymptote is at 0. So x equals 0. And if you want to go straight to domain there, you can too, because this is a normal, like if it's a negative, it shifts. But if it's normal like it is now, my parent function, my domain is 0 to positive infinity. If you want to wait to get to the graph, that's fine too. And my range is always negative infinity to positive infinity. So those things you can determine even before you graph it. Then I do my t-chart. Plugging in for the y. Convert to exponentials. So 10 picks up the y, drops off, leaving the x. And I get 10 to the negative 1, 10 to the 0, and 10 to the first, which is 1/10, 1, and 10.
How did you get 10?
The base, if it's just log, the base is 10.
Oh, yeah.
Now I've got a vertical asymptote at x equals 0. I've got a point at 1/10 and negative 1, 1, 0, and 10, 1. And then my x-intercept is the middle point on my t-chart, or from my graph, 1, 0. All right, go to the next one. So what's different this time? Say again. Good. It's got something in the parentheses, right? Which means what?
Vertical.
Horizontal shift. Horizontal shift in which direction? Always opposite. So it's to the right one, right? If it's minus inside the parentheses, it's to the right. If it's plus inside the parentheses, it's to the left. So this is to the right one. That means my vertical asymptote just shifted to the right one.
Because it's opposite because it's log.
No, it's opposite because it's in the parentheses in the horizontal shift. Horizontal is always opposite.
Oh.
So it's vertical, not opposite.
It's vertical because it's a log. No, it's a vertical asymptote because it's a log. But it's a horizontal shift because it's inside the parentheses. And horizontal shift always goes the opposite direction.
So, because it was in a parentheses, does that mean the other ones were vertical? Oh.
The other ones did not have a shift.
Oh, yeah.
So it's a horizontal shift, but it moves the vertical asymptote is what it's moving. So now I have a vertical asymptote at x equals 1. And this is going to point to the right. So my domain's also going to shift, but you'll see that in a second. Now I can do it on my t-chart. I can plug in negative 1, 0, and 1. What's the base on that log? 10. Now here's where it gets a little trickier. That 10 is going to come over and pick up the y. So it's 10 to the y equals, when it drops off, I get x minus 1 on the other side.
Do we add it?
Yep, you add the 1. So you want to get it to set equal to x. Add the 1. But that 1 is after the exponent. So it's going to be 10 to the y, and then the result of that plus 1.
Why?
Because the exponent comes from the base picking it up, That's now the exponent on that. When it drops off, this is already an expression. You're adding the 1 to it. So you'll see what happens if it goes to the exponent in a second. All right, so I get the 10 to the negative 1 plus 1, 10 to the 0 plus 1, and 10 to the first plus 1. 10 to the negative 1 is 1/10 plus 1, 1 and 1/10. 10 to the 0 is 1 plus 1, that's 2. 10 to the first plus 1 is 11. So 1 and 1/10, 2 and 11. Then I go to the graph. 1 and 1/10 and negative 1, 2 and 0, and 11 and 1 would be all the way over here. I'm just going to plot it. And then connect your points. Now we have the vertical asymptote. What's the domain? Good. 1 to positive infinity. It shifted to the right to the 1 because of the horizontal shift. What's the range? Good. Always for a log. And my x-intercept is going to come from either that center point on the t-chart or from my graph, which is 2, 0. Questions on that one? All right. Y equals 2 plus log of x. Is there a horizontal shift this time? No. What is that 2? So it's actually a shift up 2. So it doesn't move my vertical asymptote. My vertical asymptote is at x equals 0. But what it does is before I can, so once I plug these in, before I can convert this to exponential, I have to isolate that log. So I'm going to do subtract the 2. Y minus 2 would equal log base 10, because that's what that would be, of x. And then the 10 picks up that whole thing. So the exponent on the 10 is y minus 2. So if you are adding or subtracting something to your log not in the parentheses, if there is a negative on the front of the log, you have to get rid of that first before you can convert it to exponential. Now I plug in, so negative 1, 0, and 1. And I get 10 to the negative third, which is 1 over 1,000. 10 to the negative 2, which is 1 over 100. And 10 to the negative 1, which is 1/10. With me so far? Yep. Okay, vertical asymptote is at 0. I have 1/100th and negative 1. It's going to be so teeny tiny here. And then I have 1/1000th, then 1/100th, 0. So also so teeny tiny. And then 1/10th, 1. So this is not creating much of a curve. You know it has to eventually curve, so you could literally draw it and just create your curve. It doesn't have to be perfect. Or you can continue to plug in values that would be bigger than 1. So if I plugged in 2, I would get 10 to the 2 minus 2, which is 10 to the 0, and that's 1. And I would get 1, 2, so I would know my curve is still here. It would still be doing this. You don't need it though, okay? If you know it's gonna curve, as long as you have those 3 points and you can make the rest of your curve approximation, that's fine. So our vertical asymptote is x equals 0. Our domain is what? 0 to positive infinity. Our range? Negative infinity to positive infinity. And the x-intercept? 1/100th, 0. I'm going to add one in here, so I don't know if you want to duplicate your slide and change it so at least you have like the graph part of it. Okay, so we added one, so it has the negative on the front. What's a negative on the front of a graph usually do? Flips it upside down. So if my graph normally goes like this, I expect it to go like this, okay? Is there a horizontal shift this time? Yes, because of the parentheses. In which direction does this horizontal shift go? This is going to go left 3. So my vertical asymptote just shifted to x equals -3. No, it's still going to be upside down, but it's going to point to the right. Is that what you mean? So the upside down, but then it shifted left. Okay, so now I have to get rid of this negative before I can convert this into log. So I would make it -y equals log base 10 of x plus 3. Then the 10 picks up the -y. So 10 to the -y would equal x plus 3. And then the last thing I'm going to do is subtract that 3. 10 to the -y minus 3. That 3 is not in the exponent. It's next to it. And then I go to the t-chart. So 10 to the -1 minus 3. 10 to the -0 minus 3. And 10 to the -1 minus 3. So the double negative makes this a +1. That's 10 minus 3, which is 7. 10 to the -0 is still 10 to the 0, which is 1 minus 3. That's -2. And 10 to the -1 would be 1/10 minus 3, -2 and 9/10. And then I plot it. So 7, -1, -2, 0, and -2 and 9/10, 1. And there's the upside down shape curve that I thought was going to happen.
So when it's a horizontal, the thing is not like going like.
No, the horizontal shifted it to the left. The negative on the front is what caused it to flip upside down. So we already did our vertical asymptote. What's our domain? Good. It shifted to the left 3. So -3, our range. Negative infinity to positive infinity. And our x-intercept. Good. Questions on that one? Okay, so we're going to talk about the natural log, but we're going to skip it. We're going to do this in different order than the notes. So we're going to jump around a little bit because we're going to do the graphs of it. So a natural log, remember the natural base is E. The natural log is log base E. And we replace it with ln. So ln of x is the same thing as log base E of x, just like log of x is the same thing as log base 10 of x. And it's just something you have to know. Log is the same thing as log base 10. ln is the same thing as log base E. What was E? Approximately what? Do you remember? Ooh, very close. 2.7, okay? So if I was to graph ln or graph log base e, it's going to look a lot like log base 3 of x. All the same rules apply. So they still would get, you're going to convert it to log base e. You're still going to plug in for the y. You're going to have a vertical asymptote, so you're going to look for a horizontal shift. Your domain is restricted by that horizontal shift. Okay, your range is all real numbers. All that stuff is exactly the same. The difference is you're going to use your calculator to get the values because you're going to have e to the -1 and e to the 0 you could do. But all those values that other than that, you're going to use your calculator to find those values, okay? We're going to actually simplify these. I'll come back to that tomorrow because that's going to be the end of the assignment. So I'm going to try to go in the assignment order. The very end of the assignment is evaluating LNs, which we'll talk about tomorrow. Today, so we'll do all this tomorrow. Today, we're going to work on just the graphs of these, okay? So skip this and go to 36. It's like the most amount of examples I think we've ever had in notes. Yeah. Yeah.
How did we get data ahead, like, of all the other classes?
How did we? I don't know. Yeah, we just did. Remember at the beginning of the... All right, so the first thing you're going to do is say that's an ln, and an ln is the same thing as log base e. We're going to rewrite this as log base e of x minus 2. If you didn't have a calculator, you would approximate that to be log base 3, and your graph would almost look exactly the same. It's going to just be a little bit off, okay? But you're going to have a calculator if you get the graph of log. All right, so now tell me what happens. What is that x minus 2 inside the parentheses doing to this graph? It's a horizontal shift. In which direction? Right. To the right. So it's causing a shift to the right too, which causes my vertical asymptote to shift to positive 2. So now I've got a vertical asymptote at positive 2. Then I'm going to convert this into exponential, and I'm going to plug in for the y's. -1, 0, 1. So e picks up the y. E to the y would equal x minus 2, and then I add the 2. So e to the y plus 2 equals x. If you had a graphing utility, you could literally plug that equation in and you could go to your table values. If you have a scientific calculator, then you're going to make it e to the -1 plus 2, then e to the 0 plus 2, then e to the first plus 2. E is above the ln, right next to the 4. So second ln, -1, come out of your exponent, and plus 2, and you get 2.4. And we're just gonna keep it nearest 10th because you're not gonna get more accurate than that on your graph. 2.4. E to the 0 is 1 plus 2, that's 3. And e to the first is 2.7 plus 2, that's 4.7. Then I go to the graph. 2.4 and -1.
And so for the final answer, you put it in your calculator?
Yep. I mean, the first one we needed it. The other ones you don't really even need it. But yes, you would have a calculator on a question like this.
Professor, could you go back to the other?
Mm-hmm.
Thank you. Did you just put this into a calculator?
I put the first one into the calculator, and then the other ones, e to the 0 is 1, so I didn't need it there. And e to the first is 2.7, so I didn't need it there. But you could use it.
It's 2.7?
Yeah,
Why?
because that's what e is.
Oh.
So 2.4, -1, 3, 0, and 4.7, 1. And then draw your curve. Vertical asymptote was at x equals 2. Domain is what?
2 to infinity.
Good. Range?
And negative infinity to log.
Good. X-intercept?
Definitely something.
3, 0.
0.
Good. All right, last one, and then we're done for today. So what's the first thing you do when you see the ln? Log base e. Now this one's weird because it says 2 minus x. If I rearranged it, it would be -2 or -x plus 2, right? That's the order we're used to it in. The negative on the x is going to flip it over the x-axis, but we're going to let our coordinate points figure that part out. The horizontal asymptote, normally we just change it because it would be equal to, like if I had x minus 2, I would just set it equal to 0 and it get x equals 2. Because it's reversed, if I set this equal to 0, I still have a vertical asymptote at x equals 2. If I had solved, right, if I had said 2 minus x equals 0, and then I solve for x, I get x equals 2. So that's where my vertical asymptote is. What's weird about this is the direction of my curve is going to change, but we're going to get that from the coordinate points. So vertical asymptote, x equals 2. And then I'm going to convert this into exponential. E picks up the y, and you can leave it as 2 minus x or negative x plus 2. It doesn't matter. I still have to isolate the x. So if I subtract the 2, I get e to the y minus 2 equals negative x. And then I have to change the sign. So I divide or multiply by negative 1. And I get negative e to the y plus 2. That negative is not in the parentheses with it, so be careful you're not raising a negative e to a power. You're raising the e to the power, and then you're changing the sign. So if it's better to make it 2 minus y to the e to the y, you can totally switch it. Then I go to my t-chart, and I plug in. So 2 minus e to the negative 1, 2 minus e to the 0, and 2 minus e to the first. And use the calculator. 2 minus e to the negative 1 is 1.6. 2 minus e to the 0 is 1. That's 1. 2 minus e to the first is 2.7, and that's negative 0.7. Right, so it'd be 2. So you would do e to the first, which is 2.7, and then it's the minus, so it's 2 minus 2.7. It really doesn't matter with the ones. It would matter if it was a squared. If it was a squared and you got rid of the negative, that's when it's wrong. Otherwise, they're both going to end up being negative. All right, so then I get 1.6 negative 1, and I'm on the other side than I've been so far. Everything else went to the right, but it makes sense because the x has the negative. This flips it over the y-axis, which means it's going to point left instead of right. Then 1, 0, and then negative 0.71. So instead of pointing to the right, because of the negative on the x inside the parentheses, it points to the left. My vertical asymptote is still at x equals 2, but what's my domain? Good. It switches direction because the curve pointed to the left, so negative infinity to 2. My range is still negative infinity to positive infinity, and the x-intercept?
Negative,
1, 0. Good. So my advice is on the homework tonight, you're going to have to jump around a little bit. Just stick to the graphs. Do all the ones that are graphs. Okay, start there. And then tomorrow we're going to finish out the rest of the content with the one-to-one property and Ellen and that kind of stuff. And you can finish the homework tomorrow night. But if you save it all to tomorrow, it's going to be brutal. So at least get the graphs out of the way today.